Video lesson number 10, stoichiometry. Now, stoichiometry allows us to predict reactant and product quantities in a chemical reaction. So this is a very powerful tool. Now, just to review, we have 4 tools that we have talked about and been using that we're going to use to solve these types of problems and actually utilize in the laboratory. So remember, tool number 1 was Avogadro's number, relating 1 mole to the number of particles. And that number is 6.02 times 10 to the 23rd. Now, tool number 2 was the molar mass, which relates the grams to mole. So 1 mole of any substance has the mass in grams, as the periodic table says in terms of the atomic mass. So that was a powerful tool. We said we had to work a little bit for that as we added up all the masses of the different atoms. Okay. Tool number 3, the molar volume. We said 1 mole of a gas at STP is 22.4 liters. And then we just added tool number 4, which is the mole ratio. The mole ratio allows us to convert moles of one substance into moles of another substance. Just kind of like a money exchange, right? I can convert my dollars into euros, into pesos, into shekels, depending on where I'm going. That's basically the mole ratio, and we get the mole ratio from the balanced chemical equation. So let's see it in action. I've got 3 examples for you. Example number 1, okay? Okay, first example, it says 4 moles of aluminum chloride are used. How many molecules of chlorine, or Cl2, are produced? Again, first step, identify the given and unknown units. So given here, I've got 4 moles of aluminum chloride. Unknown, or what I'm trying to figure out, are molecules of Cl2. Okay, so set up your T-chart just like before. So on the left, we're going to have 4 moles of aluminum chloride. And then on the right, what am I shooting for? My target here is molecules Cl2. All right, now where am I on my roadmap? I'm right here. I've got moles, okay? And what I'm trying to get is molecules. Now, before I go right to it, what I have to recognize is I've got moles of aluminum chloride and molecules of chlorine. So I have different substances, okay? I'm okay, I can work with that, but I have to recognize that in order to get molecules of chlorine, I have to get moles chlorine. How do I get moles chlorine from moles aluminum chloride? Well, that's the mole ratio. Remember, the mole ratio allows me to convert one substance into another substance, and I get that from the balanced equation. So set up your mole ratio. We want to get rid of moles aluminum chloride. We want moles of chlorine. Okay? So these would cancel, and now I got to go to my equation and see what that ratio is. So it looks like there's 3 of these for 2 of those. Plug in your numbers. You can do it now, you can do it later. I'm just going to do it now since we're talking about it. So there's 3 and 2. Okay? And notice if I look at my units, that's the key, is always keeping those units. I've got moles of chlorine. Now, moles of chlorine, I can figure out molecules of chlorine simply using Avogadro's number. Okay? So again, set it up as before, get rid of the top unit by putting it down here, moles chlorine, and of course molecules chlorine would go on top. 1 mole is how many molecules? You probably have them memorized by now. 6.02 times 10 to the 23rd. Okay? Now, we could do that on our calculator, which I will, but really just a shorthand. Sometimes you can kind of cancel and make it easier on yourself. I can take 2 out right there, then I get 2 times 3 is 6, and really I can do this in my head. 36, and then 6 times 0.02 would be 0.12, and that would be times 10 to the 23rd. I have to recognize that's not in scientific notation, so I have to move the decimal 1 to the left. So this would be 3.6, and I'm going to round that to 1 times 10. Now, sometimes students have a problem with which way did I move the decimal. Well, keep in mind, I went 1 to the left, put it into scientific notation. To get back where I started or wanted to go in the first place, I'm 1 step further away, so I have to put 1 more on here. Okay? So that's kind of doing it without the calculator. Of course, I could type that in my calculator and get the same answer. Notice in this example, it says how many grams of ammonium nitrate are needed to produce 44.8 liters of that's dinitrogen monoxide or nitrous oxide. So again, identify the given. That is 44.8 liters of nitric oxide. And then again here I'm looking for grams. So I'll go ahead and set up my T-chart. 44.8 liters N2O. And then over here I'm going to try to get at the end grams of ammonium nitrate. Okay? You might recognize nitrous oxide. Here I am, if I'm looking roadmap-wise, here I have volume, and I'm trying to go to mass. Okay? So step one, remember, is to change the given into moles. Okay? So let's start there. I can change liters into moles, right? Liters would go on the bottom, moles on the top. Now I'm going to keep track of what substance I have. In this case, it's N2O. We cancel that. I have, of course, 1 mole is 22.4 liters. I used my molar volume tool. Okay. Now, you might recognize here I've got moles N2O. What am I trying to get? I'm trying to get grams NH4NO3 or ammonium nitrate. So really, I've got one thing. I need to turn it into another. That's the whole idea of the money exchange. I've got dollars here. I need pesos here. Okay. So I've got to be working with the same substance. How do you change one substance into another substance? You do that with the mole ratio in the balanced equation. So step number 2 here is going to be to get rid of moles N2O, and we want to get moles NH4NO3, okay, or ammonium nitrate. Okay. Now, if we can plug the numbers in right now, I look at my equation. In this case, it's 1 to 1, right? So that's actually a step maybe you thought you didn't need, but a lot of times you're going to need that mole ratio because it's just a 1-to-1 ratio. So those are canceled, right? Now I've got moles ammonium nitrate. So I could answer the question, how many grams, how many particles? In this case, it says grams. So I'm going to put moles down here. And then I'm going to need grams up here to match my answer. Okay, so moles cancel. 1 mole is how many grams? Well, that's this tool right here called the molar mass. So I'm going to have to do some work on that based off my formula. So how many N's do I have? We'll do that down here. It looks like I've got 2 N's. Each N, if I look on my periodic table, has a mass of 14 grams per mole. So that would, of course, be 28. And then I got to count up my hydrogen. How many hydrogen do I have? Looks like I have 4 hydrogen times the mass. I look on the periodic table, it's 1, so that's 4. And then I have oxygen. How many oxygen are there? There are 3, and that's times the mass of oxygen. Again, 1 mole of oxygen is 16 grams per mole. Okay, so that would give me a total of 48. Okay. If I add that up, 48 plus 4 is 52, plus 20 is 72, plus another 8 would be 80 grams per mole. Okay, so that's like a little side calculation. Now I can plug that in right here, 80 grams per 1 mole. Now I'm ready to simplify. Okay, so I can do this on my calculator. I can maybe cross cancel here so you can see I can cancel that. That goes in there twice. Okay, and so really it's 2 times a bunch of numbers and 80, or a bunch of ones I should say. So 2 times 1 times 1 is 2 times 80 divided by a bunch of ones. So my answer here is 160 grams of ammonium nitrate. Okay, so a very powerful tool, stoichiometry. Let's do one more example. So my last example, it says how many grams of, and this is chloroform, are produced if 100 grams of chlorine is reacted with excess CH4 or methane. Okay, so again, I've got a balanced equation. I can use that to help me predict reactant and product quantities. In this case, I'm looking for how much is produced in grams. So let's start with what's given. What's given, it looks like I've got 100 grams of Cl2, and it looks like I'm trying to figure out how many grams of Cl3, chloroform. Okay? So again, always start with the given on the left, which is my 100 grams of Cl2. What I'm trying to figure out here at the end is grams CHCl3. Okay? Where am I? On my roadmap, I'm here in mass, right? And it looks like I'm just going mass to mass. But what you have to realize is I've got chlorine here, and over here I've got chloroform, or CHCl3. So that's two separate substances. The only way I can exchange one substance to another, same way I can exchange, right, my dollar for, let's say, euros, okay, or yen or whatever, okay? So I got to go to the money exchange. Where's the money exchange? Well, in terms of chemical quantities, that's my balanced reaction, okay? So step one, as usual, is change the given into moles if it's not. So let's go ahead and do that. So I know grams has to go on the bottom and moles on top. Now, how many grams per mole? Well, chlorine, if you look on the periodic table, has a molar mass of 35 grams per mole. But again, there is 2 of them, so that would, of course, be 70. So I'm going to go ahead and plug that in right now. Now, for those of you who want, I'm going to show you a different way, different way to solve this one, and that's actually to work from the other side of the problem. Usually we solve it from left to right, but using the units, you can actually go this way too, and that can be helpful for some of you, okay? So if I cut it off here, I know if I'm going to have grams CHCl3 in my answer, I know that has to go on top. How do we relate grams? It's always grams per mole, right? That's the molar mass. So I'm actually working it this way, and that can help me solve the problem, okay? So 1 mole is how many grams? Well, again, I got to do that side calculation. So what do we have? We got a carbon. We got 1 times 12, which is 12. We've got a hydrogen, which is 1 times 1, which is 1. And then we've got chlorine, which is, and we have 3 of them, times 35, which of course would be 105. Okay, so I have to add all that up. Okay, so that's 106, that's 116, so that should be 118 grams. Okay, so 118 grams per mole. Okay, so notice now, definitely want to label that right there. Always labeling my units. So we have CHCl3. So if I'm looking at it like this, notice I might think I'm done, but mole Cl2 does not cancel mole CHCl3, right? I forgot that step of the mole ratio. That's what I want to do now. So I want to get rid of this. That's got to go there. I want to get rid of that. That's got to go here. So let's put it there, CHCl3, okay? And then I go to my balanced equation and put in the correct numbers. So if I look at chlorine, there's 3 of those for every 1 of those. So the 3 goes here and the 1 goes there. Cancel, 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 cancel. Now I'm ready to go. Now in this case, I am going to use my calculator. So let's see what we get here. So go ahead and type it in with me. 100 times 118 is equal to, now I divide by 70 equals, now I also will hit divide by 3. So don't hit times 3 or else you'll get messed up there. So if I round this to 2 decimal points, we should get 56.19. Okay, so there it is, stoichiometry, a few examples to chew on. This, again, is one of the more challenging topics that students have for that first chemistry class. So keep practicing. You can do it, and I'll see you in class.